continue talking about moving quadratic equations, like moving them up, down, or east or west on the xy axis. And what we're going to do now is graph another variation of the basic quadratic equation x squared, which is the example we have been using so far. But now we're going to use a slight variation, which is called y equals x minus a square. And again, a is a real number, it's a constant. So the only variable here is the x. So as you can see, there's a little bit of a difference between y equals x minus a square and, let's say, y equals x squared plus a. And again, a is a real number, you see? There's a difference between this and that. And we saw in a previous video that when we have plus or minus preceding the a, what is going to happen is that the quadratic graph is going to go either up or down, all right? It's independent from the variable x squared. But what happens if the a is inside the square? Well, it's really simple. And we're going to explain about this in another video called Displacing Graphs and Charts East, West, North, and South. So, let's say we have our xy axis, and we have a, and let's say we have a somewhere around here. So what is this operation going to do in here? It's going to displace, it's going to move the quadratic equation left or right on the x-axis, different from what had happened right here with x squared plus or minus a, would it move it up or down. When the operation of subtraction or addition is inside the square, it's going to move it left or right. And you can try this by plotting a few numbers again. Let's say we have x and x minus, and let's say 2, for instance, square. So what happens if x is 0? Well, 0 plotted here is minus 2, and minus 2 squared is 4. So what happens if we have x equals 1? Well, 1 minus 2 is minus 1. Square is 1. What happens if we have minus 1? Well, minus 1 minus 2 is minus 3. Square that is 9. What happens if we have 2? 2 minus 2 is 0. Square of 0 is 0. What happens if we have minus 2? Minus 2 minus 2 is minus 4. Square of that is 16. What happens if we have 3? 3 minus 2 is 1. Square of that is 1. Alright? You can pretty much get the pattern. If we have 4, 4 minus 2 is 2. Square of that is 4. See? Now, this looks a lot like x squared. Remember? Where 0 was 0, 1 was 1, minus 1 was 1, 2 and minus 2 were 4, 3 was 9, and 4 was 16. You see, it's the same values. The only thing is that the 0 is a little bit moved this way, and there's a little bit of a displacement of the graph a little bit to that side. Okay? The 0 is happening on 2 instead of happening on 0. Why? Because when x equals 2, 2 minus 2 is 0. It's like it pushes the chart to the right side. So if this was 2, then the chart is going to look like this. Exactly as if it was y equals x squared. It's only moving to the left side. Alright? Now what happens if, say, we have x plus 2 squared? Well, if x is 0, then is 0 plus 2 square 4. If x is 1, then we have 1 plus 2, 3 square 9. If x is minus 1, then we have minus 1 plus 2, 1. If x is 2, 2 plus 2, 4, square of that is 16. If x is minus 2 plus 2 is 0. See what happens? If x is 3, 3 plus 2, 5, square of that 25, and so on. Okay? Now, In this case, the 0 is at minus 2, so it pushed the chart to the left, okay? When it's positive, it pushes the chart to the left. When it's negative, it pushes the chart to the right. So if this was minus 2, that means the quadratic equation would look like this. A little bit over the axis. Okay? So, we're going to get to that and conclude a little bit of this and displacing charts and using constants in both inside and outside the argument of the variable to see what is going to happen with chart. And in overall, we're going to notice the following rule. When we have the function and an addition or a subtraction of a constant, the function is going to move up or down. Up if it's an addition, down if it's a subtraction. When we have a subtraction of a constant inside the argument of the function, such as here or here, if it's a subtraction, then the chart goes to the right. If it's an addition, the chart moves to the left. Again, the reasoning is because the 0 is happening more to the right or to the left side. In this case, the 0 of the function happens as x equals 2, right here. In this case, the 0 of the function happens at x equals minus 2, right here.